For this lesson, we're going to use the scale factors that we learned in the last lesson in order to apply it to scale diagrams. So we can see for the first part, great white sharks can grow to a length of approximately 6.5 meters. The diagram is a scale drawing of a great white shark. To determine the actual length of the shark, we need to know the scale used in the diagram. The scale can be given in the following ways. We can either use it as a statement saying that 1 centimeter on the diagram represents half a meter in real life. We could say it as a rate, which would say that 1 centimeter compares to 0.5 meters. Or we can do it as a ratio, remembering that the difference between a rate and a ratio means we have to use the same unit. So for a ratio, we'd have to say that if 1 centimeter is half a meter, then I would convert my meters into centimeters as well. 1 centimeter over 50 centimeters. And then they just get rid of the units. 1 over 50. So with the ratio, does not matter what units we're using. We could do meters to meters or centimeters to centimeters. They just have to be the same unit. Or we can do it as a line scale graph, which you frequently see on maps, where what it's doing here is saying that this is 1 centimeter in real life, but it's stating that each of those actually represents 1 meter. Or half a meter. The lengths of sharks are generally measured from the tip of the nose to the middle of the tail. If we measure the shark that we have on the scale diagram, we can use proportional reasoning to determine the actual length of the shark. So, if I'm measuring from the tip of the nose to the end of the tail, to the middle of the tail here, then I can measure out what this length is, and the actual measurement is going to be 9.6 centimeters. If I'm applying that back here, if the shark picture is 9.6 centimeters, then I'm going to use my proportional reasoning and say that if I have 1 centimeter over 0.5 meters, then that's going to equal 9.6 centimeters over x meters. And then I'm going to do my cross multiply. My 0.5 multiplied by the 9.6 and then divided by 1. X is equal to 4.8, which means the actual length is going to be 4.8 meters in real life. Like I said, this is frequently used on maps. So here is a map of Alberta. It gives us a legend, and it also tells us the scale. In this case, every centimeter on this map is going to be 75 kilometers. So if I'm using the line scale to approximate the straight line distance between Calgary and Edmonton, then if I know that 1 centimeter is going to be 75 kilometers, then I'm going to have to actually measure out from Calgary going all the way up to Edmonton. And if I measure out that length, what I get is 3.6 centimeters. So I can say that this would be 3.6 centimeters over x kilometers. And then I'm going to do my cross multiply again. This times this divided by this. X is equal to 270, which means the actual distance is equal to 270 kilometers. If I'm using this map of British Columbia, then I can use the same information. In this case, 1 centimeter is going to be equivalent to 100 kilometers. And the first thing it wants us to do is find the distance from New Hazleton to Prince George. Well, I can find New Hazleton up here. I can find Prince George here. And then I can calculate the distance that exists here. And this is going to be approximately 3.4 centimeters. So I can state that if I have 1 centimeter over 100 kilometers is equal to 3.4 centimeters over x kilometers, then x is going to equal 100 times 3.4 divided by 1, or 340 kilometers. Now, when it says, is the answer in A a realistic estimate of the actual driving distance between these two? The answer is not really. We have to drive along roads which are not straight lines. If I'm trying to do a better approximation, then I would need to do multiple straight lines following the roads. Which means that it's pretty much guaranteed to be longer, and then just add up the distance of all of them. All right, Tyler's scale diagram of a tower is shown. The actual tower is 240 meters tall. Write the scale that Tyler used. Well, in order to figure out the scale, I'm going to have to figure out how tall this actually is. If I measure it out, then this is going to be 8 centimeters, which means that my scale is going to be 8 centimeters over the actual height of 240 meters, which would give me 1 centimeter for every 30 meters. If I'm writing this as a statement, well, that's easy enough. 1 centimeter represents 30 meters. If I do it as a rate, I'm going to say 1 centimeter compares to 30 meters with a colon in between. If I'm doing it as a ratio, I need to give them the same units, so I'm going to say that 1 centimeter over 30 meters, and then I'm going to multiply this by 1 meter over 100 centimeters. The units will cancel out, and I'm just going to wind up with one over 3,000, or 1 to 3,000. Kylie from Abstract Renovations designs a plan for a candy store to be renovated. The scale drawing on the plan of the candy store is 1 centimeters is equivalent to 50 centimeters in real life. What are the actual dimensions of the storage room if the scale diagram dimensions are 8 centimeters by 12 centimeters? Well, I can say that 8 over x is going to be 1 over 50. If I want, I can put in centimeters in all these, which means that x is going to equal 400. For the other dimension, I can say that 12 over y is equal to 1 over 50, which means y is going to equal 600. The actual dimensions are going to be 400 centimeters by 600 centimeters, or I can divide both those by 100 and say that's going to be 4 meters by 6 meters. When it says, what are the dimensions on the plan if the dimensions of the chocolate section of the store are expanded to 3.5 meters and 4.75 meters? Well, if my ratio is going to be 1 over 50, then I would say 1 over 50 multiplied by 350 centimeters is going to give me 7 centimeters. 1 over 50 multiplied by 475 centimeters is going to give me 9.5 centimeters. The dimensions are 7 centimeters by 9.5 centimeters.